Okay guys, so in today's video we are going to be looking at exam style questions for the GCSE maths for the higher tier for the paper 1 exam. So this is like your random collation or questions from previous past papers, looking at like revision for the higher tier. Certain parts of it may be appropriate for foundation, but as I go through I'll try to point out which is higher and which is foundation. But this is predominantly for the higher tier students. So we're going to start with question number 1. Show that 4 2/3 divided by 1 1/9 equals 4 1/5. So it's dividing mixed numbers. So first of all, change them to improper fractions. So this first one, I'm going to do 3 times 4, which is 12, and then add the 2, and I'm going to get 14. So I'm going to get 14/3 divided by, well, that will equal to 10/9. So I do the denominator times the whole number, and then I add on the numerator to work out the numerator of my new answer. The denominator stays fixed as that original fraction. So whichever part of the proper fraction, the denominator stays the same for that. So dividing fractions, so it's the KFC method: keep, flip, change. So you keep the first fraction, you flip the second one, so you take the reciprocal of the second one, and then you change it to a times, for that, and then when I multiply fractions together, I multiply the numerators together, and I multiply the denominators together. Now here I can do a bit of cross cancelling, cross simplifying to make it a bit easier. So if I divide top and bottom of this part by 3, so that goes to 1, that goes to 3. These are both even, so I can halve them. That will go to 5, and that will go to 7. So I'm going to have 7 times 3, which is going to be 21, and then 1 times 5 is 5. So I'm going to have 21/5, which is my improper fraction. Now to change that into a mixed number, I say 5 into 21 go 4 times with 1 left over, so the remainder is written as a proper fraction. So the remainder is written as a fraction, so it's 4 1/5, as requested or as required. So that's my answer for this first question. So that's how we divide improper fractions. So the first step is change them into improper fractions or top-heavy fractions. You might have heard. So the process is I do the denominator times the whole number, so times, and then I add on the numerator to work out the numerator of my improper fraction. The denominator stays fixed as that denominator of that proper fraction, if that makes sense. Question 25 actually. So this is actually from the foundation tier paper. This one so this one it's basically for higher tier only, and this one it is the overlap here of GCSE foundation higher. The equation of a straight line actually is in the form 2y equals 6x plus 8. Circle the gradient. So the straight line equation has to be in the form y is equal to mx plus c. So if I divide both sides of my equation by 2, so it's in the form y equals mx plus c. So divide everything by 2, I'm going to get y is equal to 3x plus 4. 2y divided by 2 is just y. 6x divided by 2 is 3x, and 8 divided by 2 is 4. So the gradient now is the coefficient of x, and the number in front of the x, that'll be 3. So that's my answer for this first question. And that's worth 1 mark. And the answer for question 1, is worth 3 marks. For that. So simplifying algebraic fractions. So simplify this expression. I've got x squared minus 16 all over 2x squared minus 5x minus 12. So I'm going to factorize the numerator and the denominator. The numerator is a bit more easier. It's a special case. So it's the difference of 2 squares. So that'll be x plus 4 times x minus 4. On the top. And you can check by expanding that. Because the middle term just disappears. There is no linear term when you expand that. And simplify it. okay, because it goes to 4x, subtract 4x here, which goes to 0. Okay, now factorizing this here, it's a bit more trickier. Okay, I'm going to do this here by like a trial and error method. So 2x squared here is going to be 2x and x. And to make 12 here, I'm going to be careful here. So to make 12, it will be 1 and 12, 2 and 6, 3 and 4. But I'm going to be careful actually because one of them is being doubled. Okay, so if I make that a minus and a plus there, okay, because a plus times a minus makes a minus. If I put a negative 4 there, okay, and a positive 3, I can check it. I'm going to have 2x squared minus 8x plus 3x, which gives me minus 5x, and then 3 times negative 4 is negative 12. Okay, so positive 3 times negative 4 makes that minus 12, or that negative 12. Okay, I can now simplify the fraction here by dividing top and bottom by x minus 4. So they'll cancel. So my final answer would just be x plus 4 all over 2x plus 3. Okay, and that would be my final answer, yeah, for simplifying this quadratic expression. Okay, so yeah, this quadratic fractional expression. Okay, and that cannot be simplified yet any further. Okay, so when you see this in the exam, guys, think of the word factorize. Okay, this can appear on a paper 1, paper 2, or a paper 3. Okay, but this year question here is from the Edexcel spec. Okay, but it can appear on an OCR or an AQA, okay, paper as well. Okay, or the other examples here, or the other examples here, IGC and CIE and all that. Okay. So last question today. So prove that the sum of 3 consecutive integers is divisible by 3. So consecutive just means like back to back here. So think of it like this. Think about I've got the number 1, and I've got the number 2, and the number 3. The word sum means to add my answers together here. So the word sum means to add my answers together. Okay, they are consecutive here because they're obviously back to back. Okay, integer, remember, means whole number. So it means whole numbers. Okay. Okay, and the word sum in maths means to add your totals together. Okay, so you add your totals, okay, together. Okay, so 1 plus 2 is 3, plus 3 is 6. 6 is divisible by 3, okay? 6 divided by 3 is equal to 2. Now, we want to do this, obviously, algebraically, okay, for all values here of numbers. So I'm going to pick the number n, then I'm going to have n plus 1, okay, then I'm going to have n plus 2, okay? Because n plus 1 is the next consecutive number in like my sequence, okay? And then n plus 2 is consecutive to n plus 1, if that makes sense. So if I add these together, okay, and collect like terms, I've got n, which is going to be 3n. And then I've got 1 plus 2, which is going to be 3. So I'm going to have 3n plus 3. Now, to prove that something here is divisible by 3, I'm going to factor out a 3. So I'm going to have 3 lots of n plus 1. Okay? And from there, that I've proved it, because if I divide all this by 3, okay, that will just cancel with this 3 here, okay, leaving with n plus 1. Okay, so I've proved it there algebraically, okay? I've pulled out a factor of 3, okay? If you pull out a factor of 3, that means, yeah, that number will be divisible by 3, okay? Whatever the value of n is, okay? If n is equal to 0, then you'd have 3 divided by 3. If n is equal to 1, you would have 6 divided by 3. If n equals 2, you would have 9 divided by 3, okay? So this gives you the essentially the nth term expression, okay, of the 3 times tables, okay. for that. Okay, so yeah, so divisible by 3. Okay, sorry about that. Okay, and that'll be the answer for that one. Okay. Right guys, that's the end of today's short, sharp revision video, okay? This is appropriate, like I said at the start of this year, for GCSE higher tier for paper 1. It may even be appropriate for paper 2 and paper 3, okay? For Edexcel, OCR, AQA, WJEC, IGCSE, CIE, okay, the SEER exam board, and any other, like international exam board that are doing, like GCSE level material, okay? But that's it for me today, guys. Thanks for watching. If you did find it useful, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you all inside the next video, okay? Bye for now. Take care. Good luck with your revision, okay? All the best with your exams, okay? See you soon, okay? Bye for now. Take care.